Okay, so we are doing proofs with parallel and perpendicular lines. So we're going to take those theorems that we've been messing with the past couple of days, and we're going to apply them to proofs. So 3.3 and 3.4 is proofs with parallel lines. For which of the theorems involving parallel lines and transversals is the converse true? And what conjectures can you make about perpendicular lines? So we're going to prove theorems about parallel lines and perpendicular lines, and we're going to use the transitive property of parallel lines. So first off, decide whether there is enough information to prove that M is parallel to N. And if so, state the theorem we used. So I need to know if this one is parallel to this one. They told me this angle was congruent to this angle. I'm going to say yes, because notice how if we did the quadrant, so this is 1, 2, 3, 1, 2, 3, so these two are in the same position. So by corresponding angles, those two, because those two lines are, because those two angles are congruent, then those two lines are parallel. So I'll go over here and I see that I've got this angle is congruent to this one. We'll see how they're just right across from each other. Well, that has nothing to do with lines being parallel. Vertical angles have nothing to do with lines being parallel. Nothing whatsoever. And same thing here. This angle is congruent to this angle. Again, they're vertical. So no, they're not parallel. Vertical angles do not determine parallel lines. Do not. All right, so here we go. Find the value of x that makes these two lines parallel, and then explain. So what can I do? So lines M and N are parallel. So M and N are parallel when they are marked corresponding angles are congruent. So if I were to go in here, fix this up here. So if I go in here and I mark that this angle is congruent to this angle, then they're corresponding because they're in the same location. 1, 2, 3, 1, 2, 3. So they're in the same spot. So that means that 8x plus 55 is equal to 95 because corresponding angles are congruent. If I subtract 55 from both sides, I get 8x is equal to 40. And if I divide by 8, I get that x is 5. So M and N are parallel only when x is 5. All right. Here, they want me to prove that M and N are parallel. So I look at their location. So the first thing I'm going to do is this is the transversal. And I notice that my two angles are on opposite sides of the transversal. So that makes them alternate. And if I were to connect these two, that would be interior. So they're exterior. So when they are marked alternate exterior and congruent, so they need to be shown that they're congruent. So this angle equals this one. So then I would set it up. 200 minus 2x equals 130. If I subtract 200 from both sides, I get negative 2x equals negative 70. And if I divide both sides by negative 2, I get that x is 35. So therefore, M and N are parallel when x is 35. Okay. This one, they said to find the measures of the angles. So I'm just going to find the measures. But the first thing I need to do is recognize what relationship they have. So this is the transversal. They're on the same side and they're inside. So therefore, they're same side interior angles and they're supplementary. So that means I get to add them together. So you just add them together. So with that, I get x plus 2x equals 180. 3x equals 180 is x plus 2x. Divide by 3, x is 60. So that means that this angle is 60. So if x is 60, then this one is 2 times 60, which is 120. So my two angles are 60 and 120. So let's see. They want me to prove that these two are parallel. So please pay attention to this, okay? This is not hard to do. You always start with what's given, okay? So I put angle 4 is congruent to angle 5 because it is given. And then I look at the picture over here first of all. I know that 4 and 5 are congruent because it's given to me, but I know 1 and 4 are congruent because they're vertical. Because when I look at the picture, that's a fact. 1 is equal to 4 because they're vertical. So 1 is congruent to 4 because they're vertical. Now, if 4 is equal to 5 and 1 is equal to 4, these two guys are equal to these two. So that means that 1 is equal to 5 because they are transitive, okay? So remember when you have one angle that's equal to two other angles, then the one that's the same cancels out. The ones that are left over are equal by transitive. So that means that G is parallel to H. So I can now say that G is parallel to H by corresponding angles because 1 and 5 are corresponding. All right. So transitive property of parallel lines. It's the same like the transitive property we just did. Angle 1 was equal to angle 4. Angle 4 was equal to angle 5. So therefore, angle 1 is equal to angle 5. Same thing for parallel lines. If P is parallel to Q, so if P is parallel to Q, and Q is parallel to R, and Q is parallel to R, then guess what? P is parallel to R. So if you're parallel to one, you're parallel to them all. So for example, if P is parallel to Q, and Q is parallel to R, then if this angle right here is 115, then this one's 115, and this one is 115. So that means that 115 and 8 are supplementary angles. So 115 plus angle 8 is 180. So if I subtract 115, I get that angle 8 is 65 degrees. So this one would be 65 degrees. And that's all that property is, super easy. Now we're going to find the distance from a point to a line. So if I want to find the distance from point A to line BC, you find the distance of the perpendicular line. So you have to have this perpendicular line here. So if I want to find the distance from a point to this line, the shortest distance is always, so the perpendicular segment is the shortest distance between a point and a line. So I'm going to find AD. So distance, remember we're using distance formula, so x2 minus x1 squared, y2 minus y1 squared, and then of course we take the square root of all of that. So I'm going to go up here and I'm going to go -3 minus -1 squared plus 0 minus -2 squared. So this becomes positive. So -3 plus 1 is -2. These two become positive, and that's 2. So now I've got -2 squared, which is 4, and 2 squared is 4. So that's the square root of 8. which is about 2.8. So depending on which one you need to use, that's all you do. Of course, sometimes they won't give you this point right here. So sometimes you may actually have to find where the perpendicular line is, and that gets a little more in depth. All right, last part, proving theorems about perpendicular lines. If two lines intersect to form a linear pair, so remember two that make a line, then the lines are perpendicular. So if angle 1 is congruent to angle 2, then G is perpendicular to H, so that makes them perpendicular. In a plane, if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. So if these two are parallel and this is 90 degrees, this one's automatically 90 degrees. Those two are corresponding. Of course it is. So I'm going to write down here, we got corresponding. And then, of course, these two would be, and then this would be a linear pair and corresponding, a linear pair. So it's 90 degrees all the way around. In a plane, if two lines are perpendicular to the same line, so see how this line is perpendicular to this one, and this one's perpendicular to this one, then these two lines are automatically parallel, because if these two are perpendicular by corresponding again, the lines are going to be parallel. And that's all there is to that. So looking at it, determine if your lines are parallel. So I look here and it says this is 90, but it doesn't tell me anything else. There's nothing, no other information. They didn't tell me if this was 90. They don't tell me if these are parallel. They don't tell me anything. So none are parallel, because Q is not parallel. Oops, sorry, not parallel. It's not perpendicular to S. P is perpendicular to S. That's given. P is perpendicular, but it doesn't tell me Q is, so I can't assume it. All right, here I've got that this is 90 and this is 90. Since these two angles are corresponding, then P and Q are parallel. Oops, let me start over here. So P is parallel to Q. P is parallel to Q because R is perpendicular to P and R is perpendicular to Q. And then we got this one over here, which they give me that this is 90 and this is 90. Well, if this is 90, so is this. So that makes these two corresponding. So J is perpendicular, or sorry, J is parallel to K. Sorry. So J is parallel to K. And then since this is 90 and this is 90, those two are corresponding. And M is parallel to N. Okay, so that's all you have to do. Just look and see. If anytime you have a right angle, you know it's always going to be 90 on the other side if it's a linear pair. And then you just kind of start going in circles from there. So we'll do some more with this in class, and I'll see you then.